Space is big, really, really big. Planets are big. Stars are massive, and the distance between them is almost impossible for the human mind to imagine. Have you ever wondered how big is our solar system? This question might seem very simple to answer, and the answer is just one Google search away. But have you ever tried to imagine the scale of our solar system? How big can our solar system be? In this video, we will take you on a journey to explore our solar system and how big it really is. There is more to our cosmic neighborhood than just the Sun and the 8 planets. It also has dozens of moons and millions of asteroids and comets residing in the farthest part of our solar system. Our solar system is truly vast. Even though the planets are close together compared to the distances between stars, there is still a lot of empty space out there. It would take months to travel from one planet to another, even at the speed of light. And Voyager 1, the most distant human-made object, has been in space for more than 40 years, and it still has not escaped the influence of our Sun. As of February 1, 2020, Voyager 1 is about 13.8 billion miles or 22.2 billion kilometers from the Sun, nearly 4 times the average distance from the Sun to icy Pluto. That goes to show how big our solar system really is. Who knows what lies behind it? Our solar system is so big it is almost impossible to imagine its size if you use ordinary units like feet or miles. The distance from Earth to the Sun is 149 million kilometers, but the distance to the farthest planet Neptune is nearly 4.5 billion kilometers. Compare this to the farthest distance you walk in one full day, 110 kilometers, or that the International Space Station travels in 24 hours, 640,000 kilometers. The best way to appreciate the size of our solar system is by creating a scaled model of it that shows how far from the Sun the 8 planets are located. Astronomers use the distance between Earth and Sun, which is 149 million kilometers, as a new unit of measure called the astronomical unit. It is defined to be exactly 1.00 for the Earth-Sun orbit distance, and we call it an AU. Therefore, Neptune's distance from the Sun in AUs is 30.1 AU. Which is much easier to conceptualize than 4.5 billion kilometers. If we scale down the solar system to the size of a football field, the Sun is only a ball about 2/3 of an inch in diameter. The inner planets, including Earth, would be dwarfed by a flea, which is about 3 millimeters long. The vast distances between us and the objects in our solar system can be daunting, but by shrinking everything down to a more relatable size, we can gain a new perspective on just how big or small our place in the universe really is. Traveling at the speed of light, which is 300,000 kilometers per second or 670 million miles per hour, is the quickest method to move from one location to another in our solar system. Only radio waves and other kinds of electromagnetic energy can move at this speed. When NASA sends spacecraft to visit planets, scientists and engineers must maintain radio communications with the spacecraft in order to collect scientific data. However, since the solar system is so huge, radio transmissions from Earth take a long time to go out and return. So, to get a perspective on how much time it would require for us to travel to different areas of our solar system, let's sit in a spaceship and start our journey from our host star, Sun. Astronomers measure these distances in astronomical units AU, which are the average distance between Earth and the Sun over the course of a year. 1 AU is about comparable to 150 million kilometers. We will have passed the orbits of all the inner, rocky planets within a quarter hour after leaving the Sun. Mercury, 0.43 AU after 3 minutes. Venus, 0.7 AU after 6 minutes. Earth, 1 AU after 8 minutes, and Mars 1.5 AU after 13 minutes. Another 15 minutes will take us into the asteroid belt, which is home of the dwarf planet Ceres, 2.8 AU, whose orbit we will transit in 23 minutes. To reach Jupiter's orbit, 5.2 AU, in 43 minutes, we must travel almost the same distance. With progressively enormous distances between planets, traversing the region of the gas giants takes about 3.5 hours. Neptune's orbit, 30.1 AU, is 4 hours and 10 minutes into our voyage. We enter the Kuiper Belt at 5.5 hours from the Sun and stay there for 1 hour and 10 minutes. Around 12 hours into our adventure, we begin to escape from the heliosphere into interstellar space. However, crossing beyond the Oort cloud may take us up to a year. This is all if we travel at the speed of light. But how much time would it take us if we cover the same journey with Earth as the starting point and with the fastest spacecrafts humanity has right now? Based upon our current technology, we need at least 7 months to reach Mars, but it can take considerably longer if our cycles aren't aligned. Now we know we'll never go to Jupiter since it's primarily formed of gas. We may, however, travel to Europa, one of its moons. The journey to Jupiter will take around 6 years, and we did it the hard way back in 1990, utilizing Earth's gravity to propel the Galileo probe twice. Next, if we want to take a journey to Saturn, we would need at least 7 years to complete it. We will need 9 years to travel to Uranus, 12 years to travel to Neptune, and 9.5 years to reach Pluto. What about beyond Pluto? After Pluto, the distances get a little crazy. Chaos reigns 50,000 AU from Earth. At this icy distance in the cold recesses of our solar system, we find the Oort cloud. At just over 4.6 trillion miles, 7.4 trillion kilometers from the solar surface, the dense cloud is the hypothesized region at the outer edge of the Sun's influence. This portion of our neighborhood is nearly a quarter of the distance to Proxima Centauri, the nearest star to the Sun, which gives you some idea of just how far the Sun's influence extends. Some scientists believe that you could travel halfway to Proxima Centauri before you truly leave the Sun's sphere of influence, meaning that you would have to essentially travel to the next star in order to leave our solar system. Given that Proxima Centauri is 4.24 light years away, that means that the Sun's influence extends at least 2.12 light years from Earth, or nearly 13 trillion miles. That's just mind-bogglingly huge. If we ever want to cross our solar system, it would take us a staggering 30,000 years just to leave the influence of our Sun, using our current technology. That is just a very large amount of time for a human being, and not a very interesting journey too. That's not it. If you are thinking about how much time we would need to reach Proxima Centauri, the answer won't make you happy. Our solar system is over 4 light years away from the nearest star system, Proxima Centauri. In other words, it would take 4 years for light to travel from Proxima Centauri to our solar system, but that's only if we could travel at the speed of light. Unfortunately, current methods of interstellar travel would take much longer than that. The fastest man-made object is the Parker Solar Probe, which can reach speeds of up to 430 kilometers per second. But even if we could build a spacecraft that could travel at that speed, it would still take over 70,000 years to reach Proxima Centauri. The vast distances between the stars provide some perspective on the technological difficulty of astronomy, because the main star in the Alpha Centauri system is nearly the same size and brightness as of our Sun. Seeing it in the night sky is like to being in Washington, D.C. and seeing an extremely brilliant grapefruit in San Francisco, neglecting the problems introduced by the curvature of Earth. The fact that we can see the star at all is surprising, yet the darkness of the night sky permits the human eye to detect it as a faint dot of light. Through large telescopes, it seems considerably brighter, but we still cannot discern surface details of the star. The immense distances between the stars are also a grim lesson in interplanetary travel. Although science fiction films such as Star Trek and Star Wars make such travel appear to be simple, the reality is somewhat different. Consider the spacecraft Voyager 2. Voyager 2 was launched in 1977 and traveled by Jupiter in 1979, Saturn in 1981, Uranus in 1986, and Neptune in 1989. It is presently hurtling towards the stars at over 50,000 kilometers per hour, roughly 100 times the speed of a bullet. Even at this speed, it would take Voyager 2 nearly 100,000 years to reach Alpha Centauri if it were heading in that direction, which it isn't. Convenient interstellar travel is still well beyond our current technology. So how can we shorten the journey? Or is it just impossible and pointless for us to dream about going to the stars? Scientists are working on developing new propulsion systems that could potentially get us to Proxima Centauri within a human lifetime. One such system is solar sails, which use the pressure of sunlight to push a spacecraft forward. Another breakthrough is Starshot, which proposes using a powerful laser to accelerate a nanocraft to high speeds. With any luck, we may one day be able to visit our nearest stellar neighbor. Light-speed spacecraft are still the stuff of science fiction, making it exceedingly difficult for astronomers to study the solar system's outskirts. Objects circling the sun reflect relatively little of its light and are difficult to observe even at the largest telescopes. Traveling at physically possible speeds, robotic spacecraft take several years to reach the outer solar system. However, remarkable progress is being made. The twin Voyager probes, which were launched in 1977 to explore huge planets, are still sending back data as they travel further into space. The current rate of technological advancements gives us a hope to venture out among the stars. So what do you think about the size of our solar system? Will we ever cross our solar system? Let us know what you think in the comment section below. And make sure to like the video and subscribe to our channel.